Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 72. Oil of specific gravity 0.84 flows from a closed tank through 150 meters of 150 millimeter diameter pipe and then discharges into the air. If the head loss from the oil surface, which is at elevation 24 meters, in the closed tank to the free end, which is at elevation 30 meters of the pipe, is 0.6 meter of oil, determine the pressure in the oil surface needed to cause 17 liters per second of oil to flow. So to help analyze the situation, let's have the figure and put the details in the diagram. So we have a closed tank filled with oil. The oil surface is at elevation 24, as mentioned here, specific gravity 0.84, and we have a pipe and it discharges freely into the air. And this pipe end is at elevation 30 meters and the discharge is 17 liters per second to find the pressure in the oil surface in the tank. And the head loss is equal to zero point 0.6 meters of oil. So we select 2 points, one on the surface of oil and the other at the end of the pipe. So the pipe is 150 meters, 150 mm in diameter. So we will call that point 1 and this point 2. So we write energy equation between points 1 and 2, considering head loss, of course. So we have velocity head at 1, pressure head at 1, P1 over gamma of oil is also P sub O over gamma of oil, plus elevation head at 1 equals velocity head at point 2, pressure head at point 2, elevation head at point 2, plus the head loss from 1 to 2. By the way, our datum is at elevation 0 here, so that the elevation indicated in the diagram will be the assigned elevation for Z1 and Z2 respectively. So velocity head at 1 is negligible by our experience. This is a point on the reservoir. Pressure head is P sub O over gamma or PO over 0.84 times 9.81 plus 24 equals velocity head at 2 plus pressure head 0 plus elevation head 30, head loss 1 to 2.6. The pressure head is 0 because this is exposed to the atmosphere. So we can compute V sub 2 because the discharge is given. V sub 2 is equal to uh, 4 times discharge over pi diameter square. So that is V sub 2. But before that, let's simplify this equation first. So we have PO over 0.84 times 9.81 equals 6.6 plus velocity head at point 2. Then V sub 2 is 4 times 0.017 divided by pi diameter is 0.15 square. Then V sub 2 is equal to 0.9620 meter per second. Then we square this divided by 2g, which is 19.62. And the value is velocity head at 2 is 0.04717 meter. Substitute into this equation here to solve for PO. So P sub O over 0.84 times 9.81 equals 6.6 plus 0.04717. Finally, P sub O can now be computed and it is equal to 54.78 kilopascals. So that's it for this problem. Problem 73. If losses are neglected for the water flow system shown, what should the mercury manometer reading be? The left manometer leg is open to the atmosphere and V sub 1 is 0.6 meter per second. Redo the above problem if losses are 0.3 of the velocity head at point 2. So here is the given figure. Point 2 is exposed to the atmosphere, point 1 is closed. We have a pipe and we have an open manometer attached or tap into the walls at section 1. So for the solution, we have to write energy equation between points 1 and 2. For the first part, we have to ignore losses. So we have velocity head at 1, pressure head at 1, elevation head at 1 equals velocity head at point 2, pressure head at point 2, elevation head at point 2, and the head loss from 1 to 2, which is in the first part, neglected. Then we select the datum to be at 1, so that elevation head at 1 would be 0, and the elevation head at point 2 would be 3. This is 3. Velocity head at 1 has a value, pressure head has a value, this is 0. Velocity head at point 2 has a value, pressure at point 2 over specific weight of water is 0 because this is exposed to the atmosphere. Z2 is 3 and head loss 0. So substituting velocity heads, by the way, by continuity equation first to solve for V1 or express V2 in terms of V1 and vice versa, or solve for V2. Supposedly pi over 4 times diameter squares. I will not convert 75 mm to meter because this is also in mm. Pi over 4 diameter square V1 equals pi over 4 diameter square at section 2 V sub 2. So pi over 4 is cancelled and not shown here. So we just use diameter square V1, diameter at 1, 75 square times V1 equals diameter at section 2 square times V2. So V sub 2 is equal to 5.4 meters per second. And then we substitute the velocity head. We compute velocity head at 2, which is 5.4 square over 2g, or 5.4 square over 19.62. And V1 square over 2g is 0.6 square over 1962. It is 0.01835 meter, while the velocity head at 2, V sub 2 square over 2g is 5.4 square over 19.62, and it is equal to 1.4862 meters. We then substitute these values into this equation. So we have 0.01835 plus P sub 1 over 9.81 plus 0 equals 1.4862. Velocity head at 2 plus pressure head 0 plus elevation head at 2, 3, head loss 1 to 2 on the first part is neglected. So from here we can solve for P1, and P sub 1 is equal to 43.83 kilopascals. We then sum up pressure from this point, open manometer, down to this point, and we jump across here because these 2 points have the same pressure. Remember the principle for points on the same horizontal plane in a homogeneous fluid at rest. Then we rise, so minus specific weight of water times 0.6, and we equate it to the pressure at 1, which is 43.83. So again, we sum up pressure from this point to point 1 along this passage. So 0 plus specific weight of mercury 13.6 times 9.81 times h. Then we jump across here. Nothing in the equation is changed. Then we rise, so minus, this is water, so 9.81 times 0.6. 9.81 times 0.6 equals P1, which is 43.83. So from here, we can solve H, and H is equal to 0.3726 meter, or 372.6 mm. So H is 0.3726 meter, or 372.6 mm of mercury. So that's the first part. For the second part, we do the same problem, and this time we consider head loss, which is 0.3 of the velocity head at 2. So we have V1 0.01835 plus P1 over specific weight of water plus 0 equals 1.4862 plus pressure head at 2, 0, elevation head 3, then head loss from 1 to 2, which is zero point 0.3 of the velocity head at 2, or zero point 0.3 of 1.4862. So solving for P sub 1, P sub 1 is equal to 48.203 kilopascals. We then sum up pressure again from this point to point 1. So we have and equate it to 48.203. So 0 plus 13.6 times 9.81 times h minus 9.81 times zero point 0.6 equals 48.203. So solving for h is 0.4054 meter or 405.4 mm.